So let's talk about a new kind of function today that can be created, and that function is a composition function. And this is something that it seems weird, but you will see this on the ACT. It's actually a very practical kind of function. It's something you see a lot when you go to the store. For instance, I think about, some stores. If you've ever been down to Branson, to the Tanger outlet, a lot of times you'll walk in the place and they'll say, everything in the store is 50% off. And for today only, take an additional 30% off. Well, a lot of people think that if you have 50% off and then you take an additional 30% off, that would be 80% off. But that's not true. And I'm going to show you how that works. So we're going to kind of read through this example here. A clothing store advertises that it's having a 25% off sale. For one day only, the store advertises an additional savings of 10% off. Now, this is not 35% total. What we have to do is first find the sale price. So let's say we're buying a $40 sweater and it's going to be 25% off. Well, the way I think about this is if it's 25% off, then I'm actually paying 75%. So the first thing I would do is I would find 75% of $40. So 0.75 times $40. I put that in my calculator, or maybe I just know that one. And 75% of $40 is $30. So now the sweater costs $30. But now for one day only, this sweater that was now $30 is going to be an additional 10% off. So if it's 10% off, that means I'm paying 90%. So I've got to figure out what 90% of $30 is. And that is $27. That is different than 35% off. It's very different. So what happened here is the first thing I have to do is find 75% of whatever the price of the item is. Once I find the answer to that, then I'm going to do something else to this function. I'm going to find 90% of it. This is what a composition function is. You have to first find the answer to the first part and then apply a second function to that. That's a composition function. Now, it's written a little bit weird. This time, instead of, if you see something that has a little open circle instead of a dot, that means composition. It does not mean multiplication. So if it looks like this, f of g of x, that means that we're going to do the f function to the g function. If g comes first, we're going to do the g function to the f function. And I'll explain what all of this means here as we go. So let's go down here and let's look at this first problem. Let's start off with finding domain. So the domain of f, this is a linear, so the domain of f is negative infinity to infinity, and the domain of g is negative infinity to infinity. Now, eventually, we're going to talk about how you find the domain when we start doing a problem with x, but for these, we're just going to start by evaluating. So this says f of g of 7. So I'm going to have the f function applied to the g function at 7. So I'm going to start by finding out this part right here. So I'm going to go put 7 into the g function. So I'm going to have 7 squared minus 3 times 7 plus 8. This is 49 minus 21 plus 8, which is 78. So 78 is the answer to the first part. Now I have to go back and put 78 into the f function. So I'm going to have 2 times 78 subtract 5, which is 2 times 78. I'm going to have to work this out. 156 subtract 5, so you get 151. Okay, let's look at the next part. This one's backwards now. I'm going to apply the g function after I find the f function at 7. So inside here, I'm going to start by putting 7 in place of x. 2 times 7 is 14. 14 2 times 7 is 14. 14 minus 5 is 9. So now I've got to find g of 9. So I'm going to go put 9 into the g function. So 9 squared minus 3 times 9 plus 8. So I get 81, subtract 27, add 8. 81, subtract 27 is 54, and 54 plus 8 is 62. All right, let's find f of g of 1. So I'm going to find f of g of 1. So I'm going to put 1 into the g function. So I have 1 squared minus 3 times 1 plus 8. 1 squared minus 3 is negative 2 plus 8 is 6. So now I'm finding f of 6. So I'm going to go put 6 into the f function. So 12 subtract 5 is 7. All right, the last one. Oops, sorry, didn't realize you couldn't see. All right, the last one, g of f of 0. So I'm going to start by putting 0 into the f function. So I've got the f function, 2 times 0 minus 5. So 0 minus 5 is negative 5. And now I'm going to go put negative 5 into the g function. So negative 5 squared minus 3 times negative 5 plus 8. So 25 plus 15 plus 8 would be 48.